Good afternoon, everybody, and welcome to a panel session that we have this afternoon between the Decade Coordination Office for Ocean Data Sharing and eModNet. We're looking this afternoon at the role that regional data services like eModNet play in the building block, as a building block of global ocean data sharing. So my name's Adam Ledbetter. I'll be chairing the session this afternoon, and I'm the lead manager at the Decade Coordination Office for Ocean Data Sharing. I just recognize Fondation NG, who sponsor the work of the Decade Coordination Office for Ocean Data Sharing. Within the UN Ocean Decade, and I apologize, some of you have seen this slide already this week, the projects, programs, contributions are all called actions. And within the decade, what we want to be able to do is take the action of those actions to create data, be it observations, be they models, be they different acquisitions of data, manage those data, curate them, provide them through services so that we can create insights that lead to new action. And that's what the decade is all about. It's about creating action around the ocean. Some of the ways that we do that in the decade are about aligning and transforming communities together. So helping communities that have different issues or similar issues from different areas of a community align on how they submit their data to networks like the ones we'll hear about this afternoon, and just transform how they are looking after either their observations, their data, or their forecasts. I'm now going to hand over for a second brief introduction to Kate Larkin, who is the head of the eModNet Secretariat.
Thank you very much, Adam, and good afternoon to all of you. I'm thrilled to be here to present to you a regional perspective on data services. So I'll be presenting the European Marine Observation and Data Network, which is a marine knowledge asset, a public service of the European Commission, of DG Mare. I'm thrilled that we have other regions here with us today as well, and the global perspective also. So just in a nutshell, I've introduced what eModNet is, but it's actually delivered this operational service by a very large network of experts. We have coordinators in the room today who you will be hearing from as well. But in short, eModNet is delivered by 33 nations across Europe. That's 21 European Union member states and other nations. And it's really an exemplar in the open data domain by federating and having a huge network of experts to assemble Europe's capability in situ ocean observation and to standardize and harmonize this to create geospatial maps, data products that can be used by all. I'm going to go through these very quick because it's a brief introduction, but please dive into the eModNet portal to discover more. In short, we have 7 different thematic areas. We bring together marine, environmental, and human activities data, and those 7 thematics actually have 65 parameters behind them. So from underwater noise to deep seabed habitats, bathymetry, and more, you can discover eModNet. There is a map viewer where you can visualize and search data, but there's also a common metadata catalog, which is indispensable to make interoperable data for the global ocean data ecosystem as well. eModNet's not a repository per se, it's really a service with data services, web services, following different EU and international standards, all under the principles of fair, findable, accessible, interoperable, and reusable data, so that it can be collected once and used many times. Then just a snapshot of the power of open data. Imagine if one person collected a few points of data and tried to make a map, and then the power of thousands of different data collection efforts brought together, standardized, from vessel density in the bottom right to chemistry above it, which you'll hear from Alessandra. And then we do integrated products. So for example, seabed habitats, of course, you can't just collect one point of information. You need biodiversity, geology, deep sea, seabed substrate, bathymetry, hydrodynamics of the bottom currents, etc., all to make this integrated seabed habitat model, which we now have for European seas and also increasingly beyond. This is also crucial now because in Europe, you may have heard, we have new directives and laws. We have the Nature Restoration Law, and in the high seas, the Biodiversity Beyond National Jurisdiction. And services like eModNet, we are really open to collaborate with other data services, other data collection efforts to make the knowledge available for informing marine protected area and other area-based management. And then just to finish, I have 2 slides, one which is on eModNet's key contribution to the digital twin, which is just behind you. We work very closely with Copernicus Marine Service, and together we produce the data lake on the cloud to inform the digital twin. And then eModNet, as I said, has this metadata catalog, which makes its data searchable and discoverable also by machine-to-machine readability. And together, we are then developing data and metadata in global systems for the UN Ocean Decade, but also to inform UN 2030 Agenda global policy frameworks as well. Then I just finished with a picture of the full network that met a couple of years back, and looking forward to hearing from the panel. Thank you.
So I'd like to invite our panelists now onto the stage. So please come up and join us on stage. We have a great panel this afternoon. I'm not going to introduce them now because that's going to be what they're going to do in the next minute or two. If I'm right, Arianna, you don't have a slide. Is that right? Yeah. So would you like to start by introducing yourself and a little bit about your work?
Yes, of course. Thank you so much. It's really an honor, I think, to be here, surrounded by incredible researchers and people that are at the baseline of the changes that we do, because we're all informed by data, and if we're here today, it means that we believe in the power of science, and I believe in all of you guys. I'm Arianna Liconti. Nice to meet you all. I'm really sorry if this is just very busy with the background noise, but I just hope to bring you a little bit outdoor through my words today. So I work with OUTB and also with the Ocean Race, and I'm a marine ecologist myself, but I first got interested in the ocean through outdoor activities. And I feel like if you're all here today, it means that first of all, you were interested in the ocean because you love the ocean. So can I just ask, just to get to know you a little bit about you, how many of you do a sport out in the ocean in your spare time? Yes? I assume also some of the panels. Also, yeah, exactly. And I mean, you are out there, you see the ocean when you do your sport, and then you have decided to be scientists, or if you're here in this conference, it means that you're interested in doing something. And that is exactly actually the intersection in which I work. So I work in involving people that are outdoors, so the sailors and the people that are out there, and they use the sea as a playground. And then I talk with you, with scientists, and with data collectors like eModNet, in order to make sure that you can be useful to collect data out there. Because like if you do the sport, it means that you are the eyes of the sea, where scientists cannot go. So I do this both on a more coastline situation with OUTB. We're very actively regionally in Italy and in Liguria. We've been collecting data for citizen science activities for a while for eModNet. And then we do that also with the Ocean Race. So an official race that is going around the world and is collecting essential ocean data with really, really fast boats all around. And yeah, my work is in that intersection and making sure that this data is valuable for science, and most of all, they can come back to the people to be useful. And this is why I'm here today, and I'm very grateful to have the opportunity to share the stage with all of you guys. Thank you.
Thanks. Alessandra.
Okay, good afternoon all. I'm Alessandra Giorgetti. I am the head of the National Oceanographic Data Center in Italy, hosted by OGS, the National Institute for Oceanography and Applied Geophysics. And I am coordinating the eModNet chemistry, so eModNet for chemical data. And within this effort of eModNet Chemistry, I would like to present you and describe for you a few examples of sharing of data at global level. eModNet itself is a network of contributors because we have already 46 data centers connected together within eModNet network. eModNet represents regional elements, and we have provided to the Global Partnership on Plastic Pollution and Marine Litter, the initiative from UNEP, all marine litter data layers, so data and products for the digital platform. But not only, we contribute to the community of practice on data harmonization. And the same happens for the other initiative, the G20 action against marine plastic litter, led by the Ministry of Environment Japan. And they have developed an atlas focused on microplastic. In there, we provided the European component of this global picture, but also we are contributing to develop guidelines on the harmonization of monitoring methods. And last but not least, there is the initiative from UNESCO. They are developing a federated ocean carbon data system. Even in there has eModNet, we contribute to the working group. And at the end, there are also the project initiative, where we contribute, like Blue Cloud, which is developing the European Open Science platform for collaborative research. And we gather together and federate data from the European digital infrastructure and the World Ocean Database. So a few examples in place.
That's brilliant. Thank you, Alessandra. Maybe Pierre-Yves?
Yes, hello. So I'm here to represent the Copernicus Marine Service, which was already presented in many other events. Just to remind that, so we are part of the European Union Copernicus program, so providing the Marine Service, which has been an operational service for the last 10 years. So it's a user and policy-driven service, so we support all areas of the sustainable blue economy, sustainable management of the sea with large number of users. So we use satellite in-situ observation models to describe the past, the present, of the future of the ocean, both for physics, biogeochemistry, and on sea ice. I mean, for specifically this panel, so we have been working in Copernicus Marine in strong cooperation with eModNet from the start. So we are working together with eModNet to make sure that we have the best in-situ data available to validate and also construct our models through data assimilation. So this partnership has been organized from the start by the European Commission. And of course, the next step, which is ongoing today, is a large cooperation that we have as part of this Digital Twin Ocean, where the main building block are eModNet and Copernicus Marine, and where you have the demonstration today if we want to test and assess this new adventure, which is development of the Digital Twin Ocean.
Peter?
Yes. Hi, I'm Peter Burger. I'm with the Decade Coordination Unit of UNESCO IOC in Paris. First of all, being here at UNOC is just great, because if you know the decade, the vision of the decade is the science we need for the ocean we want. And if you want to do science, you need data. And wherever I am these past days, people are talking data sharing. So it's a kind of Valhalla for me. What is important for the decade is that we bring together all these global and regional data networks. So very important. The decade does not create its own data repository. It's making sure that all the data repositories that are out there, that they can work together, that they are interoperable, that they're working with the same kind of standards, etc. So really building that Ocean Decade digital ecosystem. Very important because that will help to bring people to give the data to wherever they feel comfortable of sharing their data. because obviously everybody has certain views on how to deal with data. So very happy to be here. Just another thing, one of the things we're doing there is I'm leading the corporate data group, which is a group of companies that are promoting and engaging with the private sector also to share their data for science, all the data that they have for their private projects, that they share this data for science. So that's my little introduction.
Thank you. Benoit.
All right, I'm just going to stand because otherwise I can't see my own slides. My name is Benoit Pirenne. I'm with Ocean Networks Canada, an organization on the west coast of Canada and British Columbia that basically provides real-time data from the seabed in multiple locations around the country, around Canada at the moment, even in Antarctica since a little bit. So this topic is about sharing data, right? And so sharing data starts with collecting data in a way that makes the data shareable. And to do that, you need to pay attention to one specific item that people don't always think about. That's the metadata. So the description of what you do. If you think about FAIR, the R in FAIR means reusable. You cannot have reusable data if it's not fully described, if you cannot associate where a data point comes from, precisely from which instrument, the level of calibration it has, when it was collected, and so on and so forth. Tons of details. And so that's essential for reusability. And we have become pretty much, I should say, obsessive about doing a good job there with this diagram here that shows the complete life cycle of an instrument collecting data. But I also want to highlight one of the other aspects that, of course, was already alluded to by you here, talking about IMODNET, Kate, and that's the fact that there's a lot of data types that are being collected, and when they're being collected, they can be centralized into one place. Their metadata can be described and accessible, and all that's great, but you also want the data to go to a well-curated data repository that will be there for a very long time and provide access to it. So what we do is we have a bunch of ocean observatory networks that collect data from the seabed in multiple types of disciplines. We're bringing all the data into what we call Oceans 3.0. That's our data management system. It contains all these descriptions. But then we make the data available straight to the STAR OOS, so Ocean Observing Systems, such as ultimately GOOSE, for example. Our biology data can go to OBIS. And then we use EarthScope to to deposit our geophysical data. And then, of course, the Argo data goes to the Argo Center. And then finally, from all these points, our data that's, of course, accessible straight from Oceans 3 is also accessible from these other long-term data repositories for using in models, for using directly into studies, and so on. I mean, we're doing a lot more things than that, and I would need a full hour to describe that, but just reach out to me and I can explain more about all our different activities. Thank you.
Thank you. And then Isabel.
Okay, my name is Isabel Sousa Pinto. I'm from the University of CIMAR, University of Porto. I'm also the co-chair of MMON, the Marine Biodiversity Observation Network, that is a global network that is under the framework of GeoBond, so the Biodiversity Observation Network. And so what we do is really to promote the standardization and the best practice or good practices for monitoring biodiversity and biology. And what is specific or perhaps a bit special about the biodiversity observation is that we have a lot of data. I mean, it's less developed in terms of ocean observation than the physics and the chemistry. And we have a lot of different kinds of data. We have image, so the traditional, that is image, that, and also actually visual sensors. People see animals and plants and report. But we have done a lot of advances now in imaging. So we have, and also then for recognition with the AI. So we are really progressing and really making a lot of a lot of progress on not only identifying but also localizing biodiversity with image. Then, of course, we have eDNA. Everyone is now very excited about eDNA. eDNA can give us a lot of information because not only the species but variability, so biodiversity within species. But we need still to learn. You know, this is, as you know, by the eDNA we can collect water and know what has been there, but this can be far away, so we need to still perfect that. But also we have sound, and the soundscape, this is something that is developing very much. We've been using that for whales and other big animals that really talk with each other with using underground sound. But now we have the soundscape. We discovered that a lot of other organisms really produce sound that we can identify, and we can identify also with this the landscape. And then, of course, we have animal tracking, that we track animals by satellite. So all this needs to be really combined somehow, so we have the information we need. We know what is the status of these ecosystems or these populations. And of course, we also need to combine this with all kinds of data, and actually all kinds of physical and chemical data that have to be collected in scales that let us know about how the ecosystem is functioning. Sometimes the scales are too big and really don't give us these details. So this is why it's very important to do this at global level, but also a regional level. We have MBON Europe, and what we're doing there is trying to bring together the different people or institutions that collect data that are still not sending this data to EMODNet, for instance. And EMODNet here, this is OBIS Europe, so this is actually the biggest contributor to OBIS. And also we bring them together and try to get sign MEUs so they will publish the data. So we try to standardize the collection, but also the metadata and all that to promote that, so we can have more data to share. And of course, the BIOS are known for having some problems for sharing data. And this is because until now, and still perhaps a little more some years, there is a lot of personal effort to collect data, to identify the species. And sometimes there's some difficulties for releasing this. Also, there are legal impediments. So fishery data is very, sometimes the governments don't allow this sharing. So there are some challenges there, but I think in the future, with all this technology that we have, we are also involving, and I was very happy to hear, because we are involving all kinds of data collectors, not only scientists, not only equipment, but also citizens. And this really also brings them closer to the biodiversity we want to protect. And I think I finish here for the moment.
That's brilliant. Thank you to all the panelists for those really insightful introductions. I have a few questions that I'm going to put to the panel, but have a think, because we are going to have time for maybe one or two questions from the floor as well. But touching on one of the points that Isabel made, and maybe I'd like to ask Alessandra and Pierre-Yves and Peter this question. Talking about collecting data, talking about creating data and then sharing it. And Isabel mentioned some of the challenges, but sharing data into some of these networks like eModNet and to globally raises the level of impact. So have you got some examples maybe about how the impact of the data that's been collected and shared has been raised by putting it into these global networks?
Yeah. Well, as I tried to show before with the examples that we have that I have cited, it's not only sharing data, sharing measurements, but it is really sharing expertise. It's sharing expertise in harmonizing, in harmonizing monitoring protocols at first, because if we don't if you don't monitor in a way that the final data are comparable, can be put it together, it's really useless in some sense. So the whole community is really advancing with this exchange of knowledge, of monitoring and management of data. And I think that this helps to really have a step over in the landscape.
Maybe to give the perspectives that was developed at the start of Copernicus, and I will go back to Emonet after that. When Copernicus as a program was decided, more than 20 years ago, it was very clear at the start that it will be a fully open and free service. So access to all data, satellite observation data, products from models and so on, totally free and open for all people. And this was a very smart analysis that you need to, this is a huge effort, to collect data, to make them available with all, as explained by Alessandra, all the required information on how to best use the data, so data quality, information on product. But this really allows afterwards to develop a lot of services, what we call downstream services, that could not exist before without this free access to data and products. And this really, for the benefit of all, this is really what is needed. And I think it has been a success on Emonet, Copernicus Marine, on having this free access to data and product.
Yes. Two elements to this question for me. First of all, great to hear everybody talking about open data, data sharing, interoperability, etc., which is indeed, I think, key if we want to have the benefits of all that data. But also, if you talk, for instance, if I talk to private sector companies and ask them to share data, they want to be sure that they indeed then share it with everybody and not just with one or the other. And if you look at all the acronyms on the screen every now and then, well, not now, but just earlier, private sector at times thinks, what am I getting into? So we need to explain to them that it is really open, and I think listening to us, that's happening. If you talk about impact, I always like to use this example. The seabed at the moment is mapped for 26%. So that means that 75% of the ocean sea map, the ocean's sea floor, has not yet been mapped to adequate standards. It is also estimated that an additional 20% of the seabed already has been mapped, but it's locked away in archives of private sector companies. So if we want to unlock that, we could almost double the amount of seabed mapping data available. But again, to do that, we need to provide the private sector with an open and interoperable network where they can, with confidence, share that data.
Thank you. Maybe turning now to some of the different experiences globally. Benoit, and maybe Isabelle with your NBON hat on. What can maybe the different regions learn from each other? Maybe what lessons do you think you would learn from Europe, and maybe what lessons could Europe learn from Canada? And then maybe what lessons can the regions learn from the global networks like NBON? Or what lessons can NBON learn from the regional networks, maybe?
All right, so I'll start. I think the power of the different regions and what they can bring to the table for one another lies in when they sit down together to establish best practices. And these best practices can become then standards that we can then follow. They can be coded into software to make data appear in a certain, particularly, for example, interoperable way. And so again, this is getting people together, talking, brainstorming a little bit, leading to best practices that lead to standard, that leads to code that can be shared as well to provide data that's truly interoperable.
Well, I would say that the global is good because we only have one ocean, so we really want to understand what's going on, and so anyway we part this ocean will see things that cross that border. So I think it's really good to have the global component and discuss things at global level, like for instance we do in Bonn, but also the Goose. And I would like to say here that the biodiversity, we have to connect with the whole biodiversity community that is not only in the sea, it's everywhere, but also with the whole ocean observation community. And we do this through Goose Bioeco Panel that is really observing and really bringing these best practices. So looking at for the different things that we want to observe, the different animals, different organisms, different habitats, what is the best? And that we can really talk around the world with the best experts there are. But then there are specificities that are better dealt with at the regional level. And I think Europe is a good example. Because of course, we could have each country's own data management center, and some countries actually have something. But for most countries, this would be too much to have a really good center that provides the services that EMODnet can provide. So I think this regional approach, also in terms of, for instance, in Europe, we have directives and things that we all have to respond. We are doing this in very different ways. We are collecting data, so we can still improve very much. We're collecting data in different ways, but we have similar needs for reporting and so on. So this, I think, is a good scale also to collaborate.
Thank you very much. Arianna, maybe coming to you, and I know Benoit and Pierre-Yves, you also engage with end users as well, so maybe you or maybe anybody on the panel has perspectives on this, but Arianna, I'd particularly like to ask you as well. How do you engage with users of the ocean and users of ocean data and use that to inform some of what happens with data and also to inform citizen science and projects like that can feed into some of these networks?
Thank you so much for the question. So I think when we think about end user, okay, so we go out with our kayak, for example, we bring a low-cost sensor and we collect for a sea temperature data, okay, or maybe a boat from the ocean race goes around and collects for CO2 information. Then what happens to this data? And this is why we're here, because we know what happens afterwards. And this data can be used for a variety of different reasons. So one is research, is in general going to the big databases that then you analyze, that can go into models that can inform us on what is going to happen in the future, which is, it follows a little bit the line as we cannot protect what we don't know about. So the people out there, they get to know something a little bit more about the ocean, and so that we can protect it. So for example, a little behind, so in the last Vendée Globe, which is a race that goes all around the world, really fast boats alone, only one boat collected data from the Southern Ocean on CO2 information that went also into EMODnet. And what we knew about the CO2 at that moment was so little that only that boat going to the Southern Ocean helped us to adjust the estimate of absorption of CO2 by 10%, which is a lot because not a lot of boats go in those places. So this is, I mean, collecting data for research sake, but then after that, there's the policy part, so we can actually drive policy. And it's amazing thinking that maybe me collecting some data when I'm going on my kayak or on my sailboat, I can inform a policy to protect the playground I am in. But then there's also like another aspect to it, which is I think about communication, and we call it a little bit like science literacy. Like we have heard quite a lot about ocean literacy here, but I think it comes down to science literacy in the sense that if these people, the citizen scientists, they collect data out at sea, and then they understand how this data is processed through the work that we all do, then they can actually understand how the political decisions are made, which is really exceptional. And at the same time, we think about data like through these models and the digital twin of the ocean and science, something very articulate. But in the end, we use data every day, all the time. If I have to go out with my sailboat, I check my phone and I check for the weather. And the weather is a model in the end. So actually, the more data that this citizen science collect out at sea goes back to them in the form of weather forecasts. So we can be safer at sea, which is an end use, so that we can be also more quicker, because we can choose where we go in terms of where the wind is, and maybe we can even adjust to, I don't know, how seasick we feel. We can just decide on another route to be a little bit less seasick if we work with tourism, for example. So collecting data, it doesn't give back only to the scientific community, but it gives back to the community that is collecting data itself.
Yeah, I would actually say something that will probably resonate with what you just said, Ariana. One of the programs that we have at OceanWorks Canada is one where we're basically providing indigenous communities that have, of course, a coastal access, a CTD, so an instrument that collects basic ocean information, as well as a tablet, like an iPad. And so they go off repeatedly every 2 weeks or so at some points of interest that they know of. They're using their GPS on their small boat in the region. And as they do this CTD cast, which means basically dipping their instrument into the water, 200 meters or something, then collecting it back, following a well-defined process. They're collecting data. The CTD is back on board. The data is automatically wirelessly transmitted on a tablet, and they move on to the next spot in their region. And once they're back home, the data collected on the iPad goes back to our data center, where the data will be quality controlled and turned into a product. And this is where I'm answering your question. How do we know what people want? Well, we actually go talk to them and say, how do you want the data to be presented to you? What would make sense? And what would you like to see, in other words? And so we craft data products that address the needs of these indigenous communities who want to know what's going on in their own water, because they still rely on this ocean for their own survival. So that's one example again about that.
Yeah, maybe to give some perspective for what we do at Mercator Ocean as part of in particular of the Copernicus Marine. So we are a user-driven service. So there are lots of interaction with user, which is complex. So that's just making sure that they understand the offer, that you have dedicated discussion with them, either through workshops, through meetings, through training activities. We have a lot of training activities, also through questionnaires and so on. It's also important to have a dedicated discussion with a given sector. For instance, we have a meeting with the aquaculture sector, with the marine renewable energy sector, to understand the need. Then the next step is to transform these needs into solution and products. And this can be a complex. Ariana, you mentioned that you use for weather forecast models. I mean, a user will not ask you for a given observation, or it doesn't care if it's an observation or a model, but you have to provide the best solution. And this is where we need really to bring together this user need, the solution, and to provide them the adequate product. But this regular interaction of user is complex, but this is essential. Otherwise, we are just purely science-driven, and it doesn't work.
Brilliant. Thank you very much. Maybe one last question from me, and maybe to Isabelle, Alessandra, and Peter. What's the next big challenge that you want to see addressed in sharing data?
Yes, okay. Yeah, big challenge. Well, it's all about, indeed, sharing data. So it's up to us from a technical perspective to make that all possible and interoperable. And at the same time, we need to make sure that the policies are out there, that companies, organizations are more or less obliged to share data. So it's no longer just something, oh, nice, let's do that. No, it's just a normal standard practice to share your data.
We speak of system of systems, and we have global system, but giving credit to the data originators and to the different system of merged in another system, I think that this is really a challenge, and it is really needed to get the motivation to share data at the end.
Well, I think for the biological data, we need still changes in laws. So we need to convince our governments that everyone wins if this data that has been kept is really shared. And there's been examples of that data from Fisheries Institute have been shared, and this has been, you know, an explosion of knowledge that has been coming out of that. So I think this is one, and then also that this is easier. So of course, in one hand, to train the scientists since they are very young to really how they should collect and store data. So it's easier then to really share it, so publish in this OBIS, EMODNet and others. And so I think these two areas, I think this is where we could advance much more.
Yeah. Arianna, maybe I could ask you as well, and then we've all had the same amount of chances to speak. So would you have a...
Yes, thank you. I actually wanted to add on to that. That I think if we're here, we really care about data quality, because we cannot have a good model without like fair quality data. And when it comes to citizen science, there's like, noses turn a little bit, because they're like, oh, okay, but how can I actually make sure that the data is fit enough to do that? And I think this is our role. We have the responsibility to make sure that we impose good methodologies to these projects, and we facilitate the life also with these people, because these people, like, we can receive so much data if we just allow them for easy and streamlined ways of sharing the data through the different local systems, the different citizen science project, the different sightings project also of marine mammals, or in general marine biodiversity. And I think we are getting there. Like thanks to also the European mission, we have the possibility to get funding to try to do that. But I think the word that we heard the most in this conference is probably collaboration, if we had to count how many times we heard this. But again, stressing on that, we need to collaborate with boundary organizations, with people there that can collect in situ data, with the scientists, with the data managers, with the communicators that can communicate the value and importance of this data. We need to just make life easier for people that can just send us a huge amount of data to then protect our playground back. Yes, make it easy. Make it easy.
Thank you. Are there any questions from the floor to the panel? Yes, sir.
Yes, thank you. My name is Omar. I come from the International Association. The International Organization. Now we have just changed of Marine Nature Navigation. Data is a very interesting topic, and you've talked a lot about various aspects. But my question is about the quality. How do you, if you're gathering data from a lot of sources, how do you ensure the quality? What can we do there?
So the question was about assessing the quality of data, and then in terms of integrating data, assessing the quality and maybe data of varying quality as it's integrated.
If I can start, I think that between the protocols, it's protocols monitoring, but also protocol of validating the collected data. And within EMODNet network, for example, we share these protocols, and there is a validation step at the originator level, but then at the data center level. And also this putting together information from different sources, again, gives a further validation level, because if you see some outliers, let's say, one practice that we have within EMODNet is to go back to the data originator to evaluate together the reason for a possible inconsistency found in the global, let's say, in a merged collection in a global system.
So in our case, with OceanWorks Canada, we're collecting continuously in real time data from over 12,000 sensors. And so obviously we cannot eyeball everything that comes through. So we're using automatic techniques to look for, peaks, spikes in the data, and we eliminate or mark them using Quartot standards. And for data coming from the citizen science application, we're pretty much doing the same thing. We're providing these people with a good, well-calibrated instrument. We're performing some quality control automatically, but within minutes after they got home, the quality control data is available on the web for them to look at. So we're trying to be because we're real time, we need to be quick about it. We're also using some artificial intelligence methods to look for bad data in video, for example, like what is obviously wrong. Did the lights not turn on when the camera turned on and started recording? And so all those methods we're trying to bring to bear to make sure that we exploit it as much as possible, and we can increase our data collection without multiplying the amount of people we need to make sure the data is good.
Well, very briefly, because this is an essential component of any service that is provided. So from the Copernicus Marine perspective, what we have is all products that we disseminate. They are all associated to a product quality information document, some synthetic quality overview, which are much shorter description of the quality. So this is, and we are using, as explained by Alexandra, common standards to make sure that we have the validation of the data. So this is essential, and that's really something that needs to be continued. I would also add to the fact that we broaden the user base. You can also get very good feedback from user on the products that you have. And I think this interaction with user is also essential for the system that we have. So it's critical. This is EMODnet, Copernicus, Digital Twin Ocean. That's really a key aspect of the service that we deliver, because you need to have trust of people. People need to trust what we provide. So.
Anybody else?
Yeah, just really briefly adding on to that. I know that there's, again, a lot of skepticism around the citizen science data. And as you can see, these guys are doing an amazing job and then double and triple and quadruple checking the quality of the data. But when it comes to the data collection by citizens, a couple of years ago, we wrote a paper on this, which is called Do You See What I See? And it was about marine biodiversity. And what we did, it was a very fun exercise. We invited citizen scientists and scientists to monitor for the exact same rocky shore quadrats. Okay, so we had a lot of replicates. And who do you think was the best one in identifying the animals and quantifying how many animals were in the quadrats? The citizens in the end, because they're just they care so much and they are worried they're going to fail and make a mistake, so they actually take a little bit more time and they do it more thorough. So it's not always that the less trained ones are the ones that collect the worst data. So also that.
So thank you. We're actually at time. I just want to go back to the slide that Peter Berger shared. Slightly kind of blowing the trumpet of the Decade Coordination Office for Ocean Data Sharing and the work that happens in the Decade Collaborative Center for Ocean Prediction and the Coordination Office for Ocean Observing as well. We're trying to build a Decade digital ecosystem. EMODnet is a partner in that. We're using some of their technologies into that ecosystem as well, or some of the same technologies that EMODnet uses. If you have data, if you want to be part of this digital ecosystem, even if you just want to be a user of it, the document's there. It can be found on the Decade website. You can scan the QR code, maybe. Thank you, Pierre-Yves. Yeah, and I want to pick up something Arianna said. Really resonated with my favorite phrase from the week. Arianna said, "Collaborate." My favorite phrase from this week has been, if we want to go far, we need to go together. And so, please get involved in helping us to build this digital ecosystem that will last beyond the decade and help us to answer some of the problems that we've talked about this afternoon. So please give a big hand to Kate for her talk earlier and to all our amazing panelists. Thank you very much.